Let's go for just like when they're in contact, how they will be. You think on the problem. Meanwhile, I'll finish off this. Now I'm giving the situation of like this here. After collision, this what happens. Okay, this is sphere A, this is sphere B, this is A, this is B. Why I'm showing during collision like this? Because you read the question. During collision, the velocity of sphere A will be along line of impact. What is the line of impact? I think there's a line of impact. X-axis is line of impact. Common tangent. There's a common tangent and there's a common normal. No? During collision, what happens? The velocity of sphere A will be along line of impact here. So therefore, the x-axis is what? The line of impact. So now how the impulses will act on the sphere. No? So due to this, the impulse will be in this direction. And the impulse on this sphere will be in this direction. Then the sphere A is having velocity u and is having velocity u. Now you go back, I gave initially some diagrams. With the help of that, can we trace out in what direction the sphere A can move? What is the possible direction sphere A? Somewhere I'm assuming like this, VA. What about sphere B? I'm assuming somewhere like this. Let it get there. Why sphere A will move along axis? There's a, what are the possibilities? Sphere A can come to rest, can continue to move in same direction, or it can rebound. What about sphere B? Must move in this direction. No? Why must? Because of impulse and the velocity. How do it can move? Go back. I discussed here. This is the only thing which will help you. A component of the impulse will introduce a momentum or will impart momentum along x-axis also because of y component and x component of velocity. It will move in a plane. How to trace out what direction the colliding bodies will move after impact? You must have a diagram during collision. How the initial velocities, how the impulse are acting. With the help of that, you can trace it. Otherwise, not possible. Am I right? Okay, now let's see that. What are unknown things? VB and VA, no? These are the two unknown things are there. So I'll find out now this one. Can I apply in what action momentum is conserved? In any direction. There's one advantage for you. But you conserve momentum in a direction where you can write equations very easily. What are unknown things? VA, VB, and theta. The unknown things are VA, VB, and theta. So what shall I do? I'll take help of conservation of momentum. In what direction? Along x-axis, I'll write it. So in any direction, momentum is conserved. So I'll directly write the set of equations. Pix equal to Px. So initial momentum, both are of same mass. If you want, you can take different masses M1, M2. Let me pick up same mass here. So mu is equal to MVA plus MVB cos theta. Then along y-axis. Along y-axis. Initial momentum. Mu. Final momentum. MVB sin theta. Then quotient of restitution formula. How to apply that? Along line of impact only I should apply. So I'll take this direction as the positive. Then applying quotient of restitution formula, we'll get E is equal to velocity of the sphere VB cos theta minus VA plus U minus 0. And now you can ask questions. So why you are applying quotient of restitution along X? Why don't you apply along Y axis? In what direction E is defined? Velocities of colliding bodies which are measured along line of impact. No, you should not define E for along Y axis here in this given situation. Along line of impact only the quotient of restitution is defined. Because the impulse of deformation in which direction will occur? Along the direction of impulse only. So along line of impact only the E is defined. So velocities of colliding objects along line of impact will take that. So this is equal to EU equal to VB cos theta minus VA. 3 equations, 3 unknown. Solving this will get the required answer. So you must have, this is what before collision, during collision, after collision. So a student must have these diagrams. Whenever you're discussing problems of this kind, so the during collision, the diagram they'll miss. So this is very important. So there are around 50 problems are there. You can manage all that if you can just put some small effort. You should have a patience or hard work. Drawing diagram. Say before collision already given in book. During collision, draw it when they come in contact, how the impulses will act, how the initial velocity. So with the help of impulse momentum equation, predict the direction. Then rough diagram, then right equation will be safer side. So the second diagram is what you'll miss. And you assume randomly the third diagram and you'll go wrong. This is what happens with the students. If they are elastic collision, tell me what will happen if they collide elastically. This is for E between 0 and 1. If they collide elastically, the sphere A will have, the sphere A will come to rest, and what about the sphere B? Sphere B will move in a plane. Theta will become 45 degrees. Check it. If the elastic collision, there'll be exchange of velocity along line of impact. So the topic will become unlimited. I'm telling this one, the same above problem. Above problem equal to 1. Finally, what will happen? After collision, the first sphere will come to rest. I'll show it here only. And the sphere B will move with a velocity Any reason for that? Because for the elastic collision, there'll be exchange of velocities along line of impact. And the y component of velocity will not change for B as it is. And the x component of velocity of B will be that of initial x component of velocity of V. So what is the velocity of sphere B will be now? U root 2. And it will make angle 45 degrees. So the problem, the question will become unlimited for you. You just don't confine. Try to analyze here. So if the inelastic collision, perfect inelastic collision, they'll move in the direction of common velocity. If E equal to 0, in the above problem, E equal to 0. In the above problem, if E equal to 0, then after impact, what should happen? The both combined blocks will move with the velocity of center of mass. What is the velocity of center of mass? Should be equal to mu I cap plus mu j cap by m plus m. So this should be u by 2 I cap j cap. Analysis is very important. It's not that just I'll write some equation, I'll get answer. Both will have So every problem you just make it up elastic, inelastic, perfect inelastic. What conditions will arise? You'll be in a safer side, I feel. Okay, what all we discussed, no? So these are things. So like this, you should analyze a case file. In books, what happen? Either they give one, either e equal to 1, e equal to 0, or e between 0 and 1. I'll have water. We'll discuss the next, the same colliding